Welcome to module 28 of Database Management Systems course in the IIT Madras online B.Sc program. We have been discussing about designing of relational database schemas, and we have made a lot of studies into that, and using the theory of functional dependency, we have learnt how to model and design good schema with decomposition into 3NF or BCNF. So, it is time to just kind of take a step back and start. We have done a lot of theory. So, what I want to do in this module is take a step back, stop discussing theory, but apply what we have learnt. So, you must have received the specification statement for a library information system. It is a simple English language document which describe how a library information system is required. Right? Now, when you go through this presentation, please keep that document available with you, alongside with you. I will excerpt the key points from the document here, but it is also important to understand how to excerpt the key points. There will be a tutorial on this part as well, as to from the specification how do you come to a kind of more manageable and concrete description of the specification. So, first before we proceed, let us identify the tasks. So, we are given to design a relational database schema for a library information system of an institute. The specification system document you have, and in this presentation we include the key points from the specification as excerpt as I said, and the tasks are naturally from this description we have to first identify the entity sets and their attributes. We have to identify the relationships, that is basically we have to carry out the entity relationship modeling for the specification. Once we have the entity relationship model, we will transform that into a initial set of relational schema. So, we will generate a number of relational schema that come from the ER model. Then we will have to refine this set of schema with the functional dependencies that hold on them. So, that our target would be to achieve BCNF in every case. If we cannot, we will try to do 3NF, but considering the functional dependencies, which also the functional dependencies will not be given in the document. The functional dependencies will be hidden in the statements of the document, and we will have to extract those understanding and put them in the notation of the functional dependencies, and using those we will have to keep decomposing every relational scheme to make sure they are in BCNF, and if not, at least in 3NF. And beyond that also we will have to do something is we will alongside check on what are the possible coding of some of the typical queries. All queries obviously the designer will not code, that is a application programmer's job. And we might see that my design may need some change, so that certain query can actually be efficiently written. Right. This is a factor which we have not talked about earlier. We have only been talking about the theory part of it, but there are pragmatics part of it. The pragmatics say that, well, you may have a very good design, but unless you can efficiently write queries, which is the target, the design will not be appreciable. So, that is the final stage, that we will make some refinements like this and finalize the design. Of course, then the remaining part of the task is to actually code the various queries, which we will not be doing in the module, which I will leave for you as exercise to practice, and we have already done a whole lot of SQL query programming. So, let me run through the specification quickly, before I get into the design. So, it says that the institute library has some, these numbers are not important, it just says that there are a large number of books and large number of members. And books are naturally regularly issued by members on loan and returned after a period. So, you immediately get an information that there will have to be a issue relationship, issue process, and that associated with an issue there is a time period. So, there is a date of return kind of thing that will be involved, and the library needs an LIS. Now, if you go through the sentences, you will see that it says every book has a, it was written in the longhand English, what I have just kind of bulleted them, so that it starts looking more like the ER information. So, a book, very clearly the book has to be an entity, has a title, author, in case of multiple author the first author. So, it says that it is not multi-valued, right. It has publisher, year of publication, ISBN number which is unique for a publication, and accession number. The difference between them is, say if you consider Sylvester Scott's book, it has one ISBN number. So, all copies of that book has the same ISBN number, that is a publication number, and accession number is if there are 5 copies of that book in the library, then naturally those 5 copies have to be distinguished. So, they will be given separate number, right. So, that is called the accession number, and that is what is highlighted at the end. There may be multiple copies of the book. Then you have members, 4 categories of that: undergraduate, postgraduate, students, research students, and faculty members. Student has, this is also written in terms of a description. I have extracted out and put it in terms of bullets, which looks somewhat like your ER entity relationship, entity attribute kind of. So, this is going to be an entity, and these are going to be the attributes, and these 3 are naturally value constraints. So, you are saying degree can be undergrad, grad or doctoral, nothing else, right. So, this is a value constraint. We have talked about value constraints earlier in terms of semester and all that examples, right. So, similar things you have here. So, this is a then you have faculty with all these properties that faculty has again described. Then it makes a very interesting information in terms of the membership. It says library also issues a unique membership to every member. So, you get to know that there has to be a kind of a member entity which has a membership number, and every member has a maximum quota for the number of books, right. At a time how many can you issue, and herein when you look here, herein it says what is the quota for each and every type of member. So, it talked about the type of membership earlier. So, the quota is not based on individual member, but it is based on the type of member. These are not explicitly explicitly tabulatively stated, but these are what you can read make out from the, and you can know that the quota basically talks about 2 things. One is the number of books, another is the period for which you can actually retain the book, right. So, this is basically, you are seeing the entire document. I am just reading out in forms of excerpts in a compact form, and finally it says that there are some ground rules. A book may be issued to a member if it is not already issued to someone else, which is trivial. A book may not be issued to a member if another copy of the book is already issued to the member, right. So, this is a constraint. This is a constraint being specified. No issue will be done to a member if at the time of issue 1 or more books issued by the member has already exceeded its duration, right. So, you will have to decide whether you would like to keep this in the database constraints, whether how convenient is that, or whether these are constraints for the application program, right. But these are constraints which they are talking about. No issue will be allowed also if quota is exceeded for the member, right. This should be, so this kind of a constraint will also have to be in place, and it is assumed that every author or member has 2 parts in the name, first name and last name. So, that this will help us get the atomic domain, right. because it says that this is name is a composite attribute we know, and it says what are the components. So, we will flatten out and make it simply atomic. Now, it also talks about certain representative queries like adding, removing members, categories of members, books and so on, adding, removing, editing quota of category of members, duration and so on. So, all these are basically you have to take each one of them and you will have to subsequently you will have to see whether your design can easily conveniently cater to writing the SQL query for this. If not, then you have to revise the design, and if it does, then at the end you will have to sit down and write all these queries, check if a library has a. So, there are quite a number of them. We will take just representative look at some of these. So, this is about the specification. So, you have got the specifications. Now, you are doing the design in the ER model. I am not presenting the design as in the diagram, as in terms of the diagram, rather I am presenting in terms of a text representation. So, very clearly these are the books and these are the different, this is the entity set and these are the different attributes highlighted that this is composite. So, this will have to be broken up to get this relation to 1NF, and what is given above is the relevant sentences from the specification which you are translating into this kind of a ER representation. Right? You have students which has all these different attributes, this entity set having all these attributes, and you have a value constraint on this coming from here, which you will have to remember to take care in the later part of the design. Very simple, as you see. There is a faculty, there is nothing specific to mention, except that again name is a composite one. In fact, you can in earlier ones also another point that you should have noted. For example, here you can note that this is unique. ER model allows you to note that, because certainly you can have multiple copies, multiple books with the same title, multiple books with the same author. Naturally, you can have multiple copies of CODE. So, which means that all of these can be repeated in the database except the stamping of the specific copy, which is accession number. So, accession number is unique. So, this identification of uniqueness is very important, as you understand, because you have to, after having done the basic extraction of entity and attributes, you will also have to mark the key attributes in the process. So, similarly in students, this is member number, it is roll number. So, basically both of them, a student will have a unique roll number. So, that is what you are noting. The naturally being a member of this library, you will have a unique member number. So, that is also another key. So, it has two keys. Similarly, faculty will have member number as unique and ID as unique. Another constraint written here, mobile number may be null, and here we are assuming that things like date of joining, date of birth is of date type. Since you have a date type, so that can be taken as an atomic component. You do not need to consider that to be composite. Then members, where you have member number, which certainly is unique, and then you have a member type, which has a constraint on the values it can take, UG, PG, research scholar or faculty. Now, you have a quota. So, this is what I was explaining earlier, that from this statement you are, it is not clearly quota is not a I should say it is not a tangible entity, like faculty, student or book are tangible entities, you can touch them. But quota is an intangible entity. It's a notion, it's a kind of permission that you gave. So, it is embedded in this description. So, you identify this as a quota, and what all does it depend on from the statement? A quota, to describe a quota, you need to know the member type, you need to know how many books, and you need to know for how much time. So, these turn out to be your three attributes which are not clear like you had in the description of student or book or faculty. That is how you get these. Now, the question obviously is what is the unique? Obviously, member type will have to be unique, right? Because you cannot have two different quota for the same member type. So, this is your quota design. Then it is not mentioned, but you will, I mean these kind of gaps are very typical in a specification, that when you get the specification you start doing the design, you will ask okay, all are there, students are there, undergraduate, postgraduate, research scholar, faculty, everybody is there, but how about the staff? How will the library run? There will have to be staff to run the library, and it is naturally ridiculous that if the staff who run the library cannot access the library, right. So, this is kind of possibly we will go back to the client and say that, and client say, oh my god, I forgot, thanks for the advice. So, you are trying to not only capture what is written, but at times you are trying to read between the lines in the thought process of the requirement to say that well, there has to be staff running. So, there has to be a staff entity as well, and rest of it is somewhat guesswork, which is speculation, which will have to get ratified from the customer, that certainly staff will have a name which is composite in the way the ID will be there, gender will be there, whether the staff is allowed to operate without a mobile or with a must be with a mobile is a question you will have to ask the customer. If he or she is allowed to do that, then it can be made to be null, then null will be allowed. Date of joining, there may be more, like you may want to have certain staff positions to decide what kind of membership they will have and so on. So, this is something. So, this is something very interesting. So, it is going from specification to the ER model, and what you see is some initially what we said was crisply written in the specification. Then we saw something like quota, which was written in a descriptive form and you have to dig out, and then we are talking about something which is not written at all, but you are reading between the lines and putting your thought process, and that is the contribution you make as a database designer. Otherwise, if this is missed out, later on you will have to come back and make changes, very expensive. Naturally, relationships, there could be several types of relationships you can think of, but you are looking at the library aspect. Like you can think of relationship between author and title of the book, who has written what, right? Author and publisher. But those kind of relationships you will not, we are not extracting or speculating, but we focus on the fact that it says the books are regularly issued. So, there will have to be a book issue, that is the core purpose of the library. And who can issue? A student, faculty, or members in general. So, a member number will have to be there for this. And what can be issued are books, and what is the uniqueness on that side is accession number. So, that is when we create a binary relationship, we have the key on both sides to connect the relationship. Now, we need a relationship attribute here. Why do we need relationship attribute? Because when the issue is done, at that point of time, I need to record the date, so that later on I can enforce the information on quota, right. So, this is neither in members relation, DOI is not in members relation nor in the books relation, but it has to come as a relationship attribute. We talked about this earlier. And identify the type of relationship. Type of relation is naturally many to one, because a book can be issued to only one member, but one member can issue several books. Right. So, based on this, now you can quickly, so up to that point was entity relationship diagram. If you feel more comfortable, you can write them down. I mean, you can draw them down in terms of the ER diagrammatic model, but I have just used the textual version. But from this, now you can very quickly dump this entire information in terms of the relational schema. So, you have the relational schema books, members, quota, students, faculty coming directly from that. This is your speculated one, and this is coming from your relationship. And in each you can actually mark out what is the key. This is the key, book issue. Do both need to be key? No, right? You can only have the accession number, because there is a many to one relationship. You do not need this. Member number is a key, member type is a key. Here member number and roll number are keys, two different, not together. Faculty number, ID are keys, again separately. Here staff name, I am sorry, not staff name, the staff ID is a key. If we put member number, then that will also be a key. Okay. So, this is a very basic first cut relational schema for the entire LIS system. Okay. So, what we get into is now get into the refinements. So, now we will have to see that, well, these are the relations I have got. What are the possible functional dependencies that are implicit in the statements? So, there was a statement saying that, so we are looking at books, and there was a statement saying that every publication has a unique ISBN number. So, we get the first dependency. So, this is the first functional, first FD that we get, which says that given ISBN number, I know title, author name, author last name, publisher, year, all that. And we also have that every book has a unique stamping of accession number. So, this is the other functional dependency. Clearly, in terms of the functional dependency, the key now can be formally be shown to be accession number. Now, the problem that you will get is a Koch-Silverst's book, there are 5 copies, they have different accession number, but all of these will be common for all these 5 copies, right. So, there is redundancy across this book copies. So, what we should do? We should try to normalize, right. And as we normalize, this is a very straightforward case, which actually even by observation you will be able to do. It is because it is very disjointed part of the information. So, if you look into this, then this does not violate BCNF, but this violates BCNF, right. This does not violate BCNF because accession number is a key, but the other one will violate BCNF because ISBN number is not the key. So, if we do a BCNF decomposition, we will get these two relations very clearly, right. So, both of them now are in BCNF because there are two functional dependencies, one holds on this, the other holds on this. These are the resultant keys, both are in BCNF. You can check both the functional dependencies on the decomposition. So, it is a BCNF decomposition, lossless and dependency preserving, very happy situation. So, your books relationship schema has been normalized and finalized. Then you have book issue, which has member number, accession number will decide obviously the date of issue, because why that is required, why member number is required. I was saying that accession number itself will do, it is not, it may not, because the book, same book may be issued to different members at different times. Okay. So, we will have to look at those aspects, but actually it is safe to think that this pair, member number and accession number, will decide the date of issue, right. So, that is the key, the only functional dependency. So, this is in BCNF. Quota, member type will decide maximum books, maximum duration. So, member type is a key, it is in BCNF. Members, very easy to see that member number is the key which decides member type, and there is value constraint on the member type, but otherwise this is in BCNF. Certainly, there is a question as to how do you get the member type, right. So, that question you will have to answer. Students, roll number decides everything, member number decides roll number decides member number. So, there are 2 keys and everything is in BCNF. The issue is the member number is needed for issue return queries. So, it is unnecessary to have those details with that, right. So, it is in BCNF, but it is not a good, may not be a good design, because do you really need all this information here? It is in BCNF because uniqueness is there, you know, but do you really need to keep all that? Member number can also come from the faculty. So, similarly, member number is common with again in the faculty, it is very easy to see the design, it is already in BCNF, but member number can also come from the students. How do you differentiate between them? So, that is where you get into the problem with writing a query. Suppose you have to get the name of the member who is issued the book having accession number such and such. Right. Now, where would you have to get it from? So, you have to get it from the book issue. Right. Now, if you have to get it from the book issue, so you are saying accession number is equal to this, to this. Now, the question is, what do you say, where do you get the, with this will give you the membership number, from the book issue you will get the membership number, but how do you get these details? Because from the membership number you do not know whether the member is a student or is a faculty. If he is a student, then he will have to look in the students table. If it is a faculty, you have to look in the faculty table. So, you can see that, you know, we created a design where everything has been made into BCNF, no redundancy, nothing, but we have missed out somewhere, so that we cannot effectively write the simplest query that we need to write. Who has issued a book, right? You do not know which query to fire. So, we need refinement. So, how can we refine? We have to see that the members, what we have missed out is members need to know more. Members need to know whether a member is a student or a faculty. This information is nowhere there. So, I have to basically search both these tables, and later on if I have staff members, a third table, to see, given a particular membership number, whether that person is a student or a faculty or a staff. So, what would be better certainly is to expand the member relationship. So, along with the member number, you have something, this is now your design attributes are coming, this was not stated. Now, you are saying whether member class is student or it is faculty, right, which we will use to choose the table for the answering the queries. Then member type will be there, and to relate to the details of whether it is student or a faculty, you put the roll number or the ID number. Naturally, both cannot be there, I mean rarely a faculty will also be a student, but usually both will not be there. So, it should be nullable fields, right. And here by designing this, where did we get this from? It is nowhere written, but we got it from the, again reading between the lines, that in the context of the library a student is a member, so and a faculty is a member too. So, this is a generalization available which makes this type of relationship possible, and naturally this is one to one. So, once you have made that change, now it gets easier to write the query, because you see if member class is faculty or so you have the accession number, you have the member number available from that. So, you check whether this is in student or this is in faculty, any one of them will be not null, take a union and you get the final result. So, this was just a quick way to show that well, you can have you may need to extend the design by for supporting the right queries and for doing the right design. So, this is your new members design. Similarly, your students design does not need member number anymore, because you have the roll number and member entity is taking care of that. Faculty also does not need the member number. So, they get simplified, and you have finally this relational schema. Right? There could be more and more refinements you can do, but this is a sufficiently decent schema. Everything is in BCNF, no redundancy in that respect, and at least one type of query you have tried out to sort out this concept of member coming in, which was not explicitly mentioned to be having so many different attributes. So, this has been an example. So, you please work on this, try to understand, make alternate designs and try to code the query, so that you can get a better confidence on this design process. Thank you very much for your attention, and we meet in the next module to discuss further on the design of relational databases.